Yo, I'm live again, back live, bros. And yes, I'm as you all guys know. Okay, wait, let me change it. As you all guys know, I've been doing Audacity. If you were live in my previous video, yes, I was doing Audacity, and yes, as I found out that I still have a course left for Android basic user input. So yes, I'm gonna complete it now. Live here on YouTube, you're gonna see how it feels to get informations from this Audacity course. That is really helpful. Okay, that is really helpful. Okay, I just completed something. Let's start the video.
Quiz, let's review the actual syntax rules in Java for defining a method. This is also known as the method signature. This is the method signature for the calculate price method that we saw earlier. You might be wondering why the order of the words are a certain way. Well, they follow a specific format, and it looks something like this. I know this looks really overwhelming, but don't worry, we're going to go through each one at a time. The first part in this method signature is the word private. This is known as the Java access modifier. It determines who has access to this method, calculate price. The most common access modifiers that you'll see are public or private. This method is marked as private. That means that calculate price can only be called within other methods of the main activity. Outside of the main activity, like in other activities, you won't be able to call this method. It's private to the main activity. On the other hand, if you mark this as a public method, then anyone could call this method, whether you're inside the main activity or you're in other activities. It's kind of like this analogy. If you're a celebrity and public, then everyone knows about you. If you're private and you live inside your house all the time, then only a couple of people know you.
That's right. If you are streaming, then everybody can watch you. If you're not streaming, then no one can watch you. That's similar to that, okay?
So for the calculate price method, we're going to keep it private, so it's only used within the main activity. Next we have int, which is the return data type. Do you remember our diagram from earlier where we said that when you call a method, you pass it inputs and you get an output back? Well, the return data type is the type of data that is returned in the output. And the data types we've learned about so far are int and string from the last lesson. This can also return an object data type, and we'll learn more about objects later in the lesson. In our case, this calculate price method is returning the total price of the order, which is an integer. In a social media app, if I had a method to get the number of friends I have on Facebook, it could return an integer, which is the number of friends. Next, we have the method name, which is calculate price in this case. Just like how we can refer to variables with their name, we can refer to methods with their name so that we can execute the instructions in this method. In the same documentation about defining methods, we can scroll to tell that forward. We don't want any of this, but the name that we choose for it. So from the diagram of inputs and output, this is going to be the first input to the method. Within this method, then you can refer to the quantity variable. You can one list of all the instructions within your method.
This is all the basics of Java that I know.
Wait,
What's wrong?
when did this turn into a cooking show all of a sudden?
Well, since we had to talk about methods.
Care to explain, Rachel Ray?
Well, have you ever baked a cake before?
I have eaten a cake before.
Okay, well then you're fully qualified for this.
Okay.
All you have to do to bake a cake is to put in like flour, sugar, and
The ingredients. Okay.
Yeah. And then you follow the instructions of the recipe.
Okay.
And then
How do I make
out
it
comes a cake.
Like this?
Yeah.
How?
Okay. Well, connect the analogy to the methods one
How the fuck did you do that?
more time. for
Okay,
me.
sure. So for a method, you can put in inputs.
Like we did the quantity for the display method.
Yeah. And then you execute the instructions of the method.
Okay. Almost like the recipe for making a cake.
And then you can have an output value returned.
Outputs, they are delicious.
Let's look up more information about input parameters for methods. I'm going to do a Google search for Java method parameter. The first link looks good, so I'm going to click on it. Now this article talks about passing information to a method. Here's a code snippet that computes the monthly payments for a home loan. It has 4 input parameters: loan amount, interest rate, future value of the loan, as well as the number of periods or the length of the loan. And then inside this method, we see that we can use these input parameters simply as variables to do our math calculations. When we call the compute payment method, we have to make sure we pass in the inputs in this specific order. So the loan amount has to go first, and then the rate, and so on. For the quiz in this section, you'll have a chance to review this article in more detail. Within the main activity of the Just Java app, we're going to be modifying the display quantity method and the input parameter to give you some practice. Notice that in the decrement method of our app, when we call the display quantity method, we're passing the quantity variable over as input to this method. But the input parameter is called number, so whenever we want to refer to this input, we just have to say number. That's just patch it to the app and on the input method parameters. Inits are the actual inputs in your method declaration, and those are the variables that are used within your method.
Fuck you, homie.
I'm going to walk you through an example of a method with a different number of input parameters. I started by creating a new app from the project wizard in Android Studio. So this is completely unrelated to the Just Java app. I added this method in the main activity. It's called createWeatherMessage. There's no input parameters, and the return value is a string. This method is supposed to create a new message that specifies the city name and the temperature. You can think of a method as being a template of instructions. So I can make temperature be an input parameter. And it's a number, so I'm going to say int temperature. And then I can use this right here. So this is a string literal, and then it's concatenated with the temperature integer, and then it's concatenated with another string that says degrees Fahrenheit. So now the message can be customized based on the temperature because it's an input parameter. Oh yeah, I forgot to mention this earlier, but in the onCreate method of the main activity, which is called when the activity gets created, I can call everything and then type used to structure that always here. Its signature now it has in the city by the parameter see they or note that it only has one input parameter. Then in the submit order, try to model changes in the pink line. Then I
Everything. I'm a genius. What is this now?
We just finished calling a method and passing in inputs.
Oh wait, are you referring to passing in quantity to what was it, the calculate price method?
Exactly. And now
I just don't understand what he speaks. He speaks so fast.
we just finished
You don't have to be that fast in speaking English, please.
calling a method and passing in inputs.
Oh wait, are you referring to passing in quantity to what was it, the calculate price method?
Exactly. And now we want to get we just finished calling a method and passing in inputs.
Oh wait, are you referring to passing in quantity to what was it, the calculate price method?
Exactly. And now we want to get a return
I still don't understand you.
value out of it.
I love return values. What is going to be, I think, the price, because it's the calculate price method?
Yeah, the total order price is going to be the return value.
Okay, let's do that.
Okay. Do you need a fork?
Do what?
He's an Indian. He don't need fork. Just if you're an Indian. Bam.
In Java, the output
9, 11.
of a method is known as the return value. In code samples, you may have seen the word return inside the method or seen the word return in the comment above it. Let's look up more information about the return values for methods. I'm going to do a Google search for Java method return value. The first link looks good. This article talks about returning a value from a method. Statement to turn come you can just put name of string the content does delete the job don't that you find
Bye bye. Next. use this.
Let's go back to the calculate price method. Once we call this method, it's going to return the total order price, and we can store this value inside this variable called price. Then we can display it on the screen. To integrate the calculate price method into our app, we're going to need to use return values. Let's look at the pseudocode first. Within the submit order method, we want to call the calculate price method. It's going to compute the total price of the order, and it's going to return that as an output. So we're going to store.
What is this? The meaning of the star and this? Resources.
All right, we just learned a lot about methods. Now it's time for you to take a break. You can do some jumping jacks, you can go take a walk outside, you can even go to a new browser tab. When you're ready, you can come back here, and then we're going to look into the display message method, one of my favorite methods. In the next coding task, you're going to modify the app so that instead of saying price here, it's going to say order summary. This is a better name because if you change the quantity and then hit order, then the summary does show up here. It's more than just the price. This is a small UI change, but in the process, you're going to be modifying the display message method, which we gave you in lesson 2 without explaining what it really does. In the coming videos, we'll start to understand more about all the different parts that are going on inside this method. You'll begin by experimenting with changing some of these values and seeing what happens. When you make the change, it will cause an error in the display price method, so you can actually delete this method now. You even get a warning now that says that this method is never used. So go ahead and delete it. The overall goal is to change the price section to be called the order summary section. There's a couple of additional changes we'll be making along the way. In the activity main layout file, go ahead and change the price header to say order summary. Then find the text view for the price value, not the header, but the actual value. Change that view to have an ID of this. The view ID used to be something like price text view, but now that we've changed it into an order summary section, we're going to update the ID as well. Then in the main activity file, in the display message method, go ahead and change the variable name from price text view to order summary text view. And lastly, go ahead and change the reference to r.id.price text view to r.id.order summary text view with the underscores here. When you're done, check these boxes. Then take a moment to step back and make any observations about what's happening in the display message method. Do you have any guesses about what's going on or what the connection is between the XML layout and the Java file?
Stop, bitch. You are overwhelming me with knowledge. Okay, stop it for now. Let me do it. You want me to remove that price? You want me to remove this beautiful thing that I just made by playing with some relative layouts and stuffs, and you want me to did this app work? I'm a little curious. Wait. It works. I can't show it to you, but it works. Yes. For 5 cup of coffee, it's 250 rupees. It's showing, guys. You can't see it, but I've made it. Okay, I've made it. I made the app. Anyways, I have to make some more changes to make this summary thing. I think I should give the layout weight as 3. What the fuck? 3. This, oh my god. Oh wait, 1. Look at that. Why did I give layout weight 3? It doesn't even work here. Damn. Okay. Layout weight as 2, cause like balance. Okay. Layout weight as 3. Come on. Okay. I think it's a balance now. It's still not balanced. What the fuck? Where is the layout weight? Not responding. Okay, just hold your breath. Hold your breath. Hope it doesn't mess up, please. Okay, let's just revise what we learned. Okay, private and public, they are called access modifiers. Int, char, string, they are called return data types. And calculate price, which is that name, is called method name. Oh, it works. It worked. It worked, guys. It worked. Okay, where are we gonna go? We're gonna go with relative layout width there. It's equal. The weight is equal. And why isn't it? Why does it have more weight than that? Okay, let's just give weight as 1. That makes a little more sense, but let's give 3. I don't know why this is occupying more space than this below relative layout. There might be some reasons. Actually, let's leave it. What did they want me to do? They want me to make something like this, right? Order. Okay, they want me to make order summary instead of price tag. Okay, let's just give this as order summary. We're gonna change that in future. We're gonna give an Android text saying that it is order summary, and I'm not gonna have this center horizontal. Oh my god. Okay, I need margin to 16 dp. 16 dp. I need margin. Oh, I really need margin. Actually, even though if it's 8 dp, I need margin. 8 dp. No, it's 16 dp is fine, right? 16 dp is fine. Margin order summary. It's order summary. Saying order summary, and I want to create another. Oh my god! For fuck's sake! I want to create a linear layout. What do we want? Name, quantity, total, and thank you. Okay. Name, quantity, total, and thank you. Name, quantity, okay. Maths, parent, maths, parent. Around my room, my world so bright. Na na na, but that's alright. Dun, 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 dun. I'm just gonna cut that out. I'm gonna paste it there. Oi! Not Matt's parent. It's matching that fucking parent. What is wrong with that? Okay, I should just give wrap content. I like this. Linear layout and Android orientation to be vertical. Yes. It's a text view. Now what we need is text view for name. text view for wrap content. No. Okay, let's just do wrap content. Text view, Android text, which will give you name, I guess, and Android ID saying that it is a name. I think it's gonna be like name of, oh, I shouldn't have space, name of user. All right, that's the ID. That's what my ID is gonna be, and it should be black. Okay, I should just give Android text color. Android text color is equals to hashtag 1234566 zeros, name, and it's working, guys. It's working. Oh my god, I should just give slash this to work, right? Come on. Is it the wrong slash? Why? Linear layout. It's of that. Do I have any mistakes? No, I don't. Text view saying name, and what other text view do we want? Oh, and then quantity. Okay. Text view saying wrap content, Android text saying it's a quantity, Android color to be, okay, text color to be hashtag 1234566 6 zeros and backslash, and in the text view we have quantity. What do you want to give is that a little semicolon to make it a little beautiful, and we need a total price. Android, oh my god, can I add something like ANDROID Android? No, I think I can't. Text is equals to total. No, it doesn't work. I'm not giving there. Might work, but let's leave that for a while. Okay, I'm just bored. Okay, I'm just gonna copy paste. Amount AMT quantity. Okay, I'm just gonna give an ID to amount quantity AMNT QUANTITY, and this ID should be total price. Let's say price tag, PRICE tag, if I do remember, which is it, price tag. Okay, I have capital P and small t. Oh, T. Okay, it might work. Price tag, total price tag. Then a text view giving its wrap content, and this will just, okay, total and just saying thank you, right? And a text saying thank you. That's it. Thank you. That's the program that we want. I want to execute it in my mobile phone, whether it will work or not. Come on, show the device. Okay, it's Xiaomi. It's Xiaomi. Xiaomi. I know how to pronounce Xiaomi, okay? Xiaomi. Come on, coffee shop. I want you in my ass. I'm kidding. I want you. Do it. Come. Hey, do it. I just want you in my. Hey, do it. Come. Who's watching me? I don't think anyone is watching me. Oh my god, I'm scared. Close videos. Oh my god, I instantly get 3 views. Guys. Look, I'm live right now. I have to watch my video. Oh my god, we'll go to live control. Oh, the app didn't work. Mayday, the app didn't work. Okay, no one's watching. Anyways, Mayday, the app didn't work. Mayday. Where should I go? Oh, it's still running. Come on, run already. Android older summary. It's taking here a lot of time. Okay, completed. Okay, it did work. It worked, fellas. I'm just gonna complete the course by completing what some of this will work. Okay, I can't modify the name already because I don't know how to do that for now. Just leave that. Let's check for the other. Let's go for quantity, I guess. Quantity. Okay, I just have to got him. What I have to do, I know what I have to do. I just go to main.java and display price, display number. Yes. And what I have to just do is text quantity TV, text view, quantity so. I'll just copy this shit. Right. No. On click, order button click. When order button is clicked, I want to display display is not gonna work. Quantity.tv, quantity TV, it will just, oh my god, this is so hard. And we'll try something else that might work, like this, like the thing that I'm just gonna do. Quantity TV, quantity TV. Oh, display price. I can modify this. Not price tag. Let's say quantity quantity amount. Okay, and I want that to come here. Amount. And it should give like, okay, you know what, it should give quantity like this, and the number. It's not just gonna take number, okay, it's gonna take quantity too. Quantity number 2. Number, it's gonna take price, and it's gonna take number. Let's say, okay, let's keep quantity 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 amt amt, and this is gonna be like price. I think I fixed one. I fixed that one, price and thank you. Oh, I think I did it. Wanna try that out? Let's do it. Run the task. Oh my god, class interface. Where did you expect where? What did you expect where? Where did you expect what? My god. Okay. Where did you expect what? Wait. I can't see the error. Quantity number int quantity. Oh, it's price tag. There are 2 price tags. One shouldn't be price tag. Oh, actually, oh yes, that's price tag. The other, what is it? Let's go to quantity. Okay, quantity, it's AMNT quantity. Okay. Okay, this might work. This will work. Come on. enum. What do you okay. Even I should make that work. It should be total instead of that. Right? Now it works. Price. Where are you expecting what? Error found. Where's the error? Come on, show me the black fucking thing. red thing that you saw. Oh my god, price. Quantity AMNT. Is that the either typo in word more? Inspection, it says spell checker. Inspection helps locate typos and okay, how do I fix it? How do I fix it? Let's just keep that quantity number. Quantity number, it's private, right? Okay, it must work. Oh, I guess it's the error that is being shown. Does it work now? It did work. There was one exclamatory sign that was missing. Fucking shit. 4 0. It worked, Tommy. I can't show it to you, but it worked. Coffee shop app. It really works. My god, I'm an app developer now. What should I do? Oh, I have to watch the video now. Android basics. Okay, I think I've completed everything.
In the last quiz, I asked you to modify a bunch of things in your app. You may not have understood what you were doing, but that's okay. We're going to talk about it now. Specifically, we're going to talk about resources in your app. Resources live under the res directory of your app. Res is short for resources. On the other hand, Java files live in the Java folder, and we have mainActivity.java located inside this folder. An Android app is primarily made up of resources and Java code. The Java code consists of files like mainActivity.java. Altogether, it handles what should happen when the app is running, like responding to button clicks or other events. Then you have resources that live in the res directory of your app. This includes images, text strings, colors, dimensions, like for width and height, XML files, like for menus and layouts, as well as raw media files, like for audio or video. One of the major advantages to separating out the Java code and the resources is that we can provide alternative resources to make the app look better on certain devices. So if we want a different layout on larger screen devices, we can provide that by just swapping it out. Or if we want to translate these strings into another language, then it makes it easier to swap out the strings in just a centralized location instead of having it scattered all over the code files.
Half of these things, I'm not understanding it, okay?
Now that you know what Android resources are and that you can put them in different folders, let's talk about how you can actually access the resources that you saved in those folders. When your app is compiled, there's a tool in Android called AAPT, and that generates the R class. This is simply an r.java file, and I'll show you an example next. It contains the resource IDs for all the resources in your res directory. So for every resource that you added, now there's an ID to refer to it. The ID is in a format that is based on the resource type. So for all drawable resources, which are graphics, it would follow the format of r.drawable. For all strings that are resources, it will follow the format of r.string, and then the resource name, which is hello in this case. Note that there are two ways that you can access a resource. In Java code, it follows the format of r.resourceType.resourceName. In XML, though, it follows the @ notation. So it'd be @ and then the resource type, which is string, / and then the resource name, which is hello. Here are more examples of different resource types and how to access them. These are just a couple of the common resource types, but there's many others. Just remember that in Java code, you always start with a capital R, a dot, and then resource type, a dot, and then the resource name. And the name is whatever name you assign it. And then in XML, you have @ and then the resource type, / and then the name of the resource. Let's take a moment to find all the resource IDs in our main activity Java file. I'm going to open up the find command in Android Studio. I'm going to use Command F, or you can use Control F if you're on Windows. It pops up a search field here. I'm going to search for capital R dot, and then click on match case so that it only grabs the capital R cases. The first thing it finds is this r.layout.activity_main reference. This is interesting because we're referring to the activity main layout file. This is actually how the main activity knows to load up this XML file. Isn't that cool? Let's look at the next reference. Okay, in the display quantity method, we have a reference to r.id.quantity_text_view. So this is referring to a view ID, specifically the text view that displays the quantity. Hopefully some of the puzzle pieces are coming together. By referring to this view in the Java code, we can update it while the app is running to show this number of coffees. Let's go to the next occurrence. Okay, in the display message method, we see a reference to
big thing that we can see in our phone.
r.id.orderSummary text view. Here it seems like we're trying to refer to this text view that displays the order summary so that we can update it with this message. Now we know that we can refer to XML resources in the Java code. But what exactly is the relationship between the resources in the Java code? How do they come together as part of a full app experience? Let's start at the point when you click on the Just Java app icon. It opens up the main activity. Now you don't see anything yet because it's still being initialized. Thankfully, a lot of the complexity involved in initializing the activity is handled automatically for you by Android. The important part that we care about is that in the main activity file, the onCreate method gets called automatically. This is when the activity is getting created. It does a bunch of work, and then we have an important line that says set content view and then the resource ID for the layout file. It's r.layout.activityMain. This means that the content view of the activity should be set to the layout as specified in the activity_main XML file. This is the method call, and the input parameter is this resource ID. Once you set the layout that you're going to use for the content view, then the Android device can go ahead and start parsing this XML layout file. Parsing is like reading this file and trying to interpret that, like, oh, this is a linear layout, oh, this is a text view, these are the attributes, and so on. So it's trying to understand what this file contains. The Android device starts by reading at the top of the file. It recognizes that there's a linear layout here. Then it inflates a Java object to represent that linear layout. Then it goes to the next line and sees that we need to add a text view as a child to that linear layout, like that. This is starting to look like the view hierarchy from lesson 2. What I didn't tell you earlier is that this is actually a hierarchy of Java objects. We're going to be learning more about Java objects in the coming videos, so it's okay if you don't fully understand it yet. When we get to the next line, we see that we need to inflate a linear layout Java object. That gets added as a child to this root linear layout. Then we see a button element, so we add that as a child to the linear layout. So we continue down the file until we've inflated all the views that we need for our view hierarchy. Once we have this view hierarchy of Java objects, then we can manipulate them and change them while the app is running.
What's the meaning of inflate? I knew it, but I forgot. Inflate. Fill.
An object like the text view here contains state information, like the text color, the text size. The object also has methods, so we can call those methods and change that internal state. So for example, we can change the text while the app is running. Interacting with all of these objects is called object-oriented programming. We will cover this in more detail in the coming videos. So to summarize, in the main activity when we call setContentView to this layout, then we read this layout and then inflate a bunch of Java objects. These Java objects make up the view hierarchy of the app. The main activity holds on to this view hierarchy, and then as you interact with the main activity, it can update these objects.
She said, I only
Do you remember the boxes?
What boxes?
These boxes.
Huh.
You do remember them?
Oh yeah, I do remember them. They're variables where you can put the value inside.
Yeah, and you can combine multiple of these variables to create a larger Java object.
Oh, okay, so you can take 2 or more variables and make into something bigger.
Exactly.
Okay. Like a text view.
Yeah, so we can have an integer variable.
This is for the font size.
Exactly.
Okay.
And then you can also have a string variable.
And the string variable for the actual text itself.
Yeah. And those can go inside the text view as the state of the text view.
And then we can interact with those things using different methods that we're going to play with next.
Exactly.
Okay, let's do that.
As we mentioned earlier, showing a text view on the screen like this is actually controlled by a Java object within the app. This is an example of a text view Java object. It's like a box, and inside of it, it holds state. The state is made up of a bunch of fields. A field is a variable, like in lesson 2 when we learned about global variables. We can have a text field to store the today string, which is going to be the text that's ultimately displayed on the screen. We can also have an integer field to store the font size of this text. There's also a bunch of other fields like text color, font family that make up the state of the text view. I just didn't draw them in this picture. To interact with this Java object and change it while the app is running, we can call methods on the text view. We learned about methods earlier in lesson 3. Some example methods on a text view are setText and getText. You can also have methods like setTextSize or getTextSize and so on. Each of these methods just executes a list of instructions. You can have more complex methods like onDraw, which handles drawing the text view onto the screen. So overall, this text view object holds state information on what this text view contains, and you can call methods to interact with this text view, such as to modify the state or to do more complex actions. To show an image view on the screen, we actually have a Java object for image view inside of the app. This particular image view contains state information like which image should be shown, as well as the scale type, like center crop. Again, there's a bunch of other fields that make up the state of an image view. I just didn't draw them here. There's methods like setImage, setScaleType, and even more complex methods like onDraw to handle drawing this image view onto the screen. Note that as developers, we don't explicitly have to call onDraw to tell it to draw onto the screen. Android handles calling this automatically for us. But it is useful to be able to call these methods to change the image view, for example. So how do we know what all the fields are inside the state of an image view and what all the methods are of this image view? To answer that question, we have to look at the class definition for that object. It's a file called TextView.java, similar to how we define mainActivity.java. Inside this class TextView file, we have a bunch of code that talks about the state of the TextView as well as the methods. Now, it doesn't say state and methods exactly, but it just contains information on the state and contains information on the methods. You can think of this as defining the rules of how a TextView behaves. This object instance can hold specific information like the text string today or the text size 18. You can also use this class to create even more TextView object instances. And these could have a different text string value, like this one could hold text that says hello, and this one could hold text that says goodbye. They could have different font sizes, different text colors, and etc. However, they're all based off of the class template. You may find it hard to distinguish between a class and an object instance, but that's okay. It takes some time to get used to. Here's an analogy to help you. You can think of it as creating a floor plan for a house. You can use this floor plan to create the actual homes. Each of these homes can be slightly different, but they're all based off of this base floor plan. It's important to note that the floor plan is not a house itself. It's just a plan. Similarly, the TextView class is used to create these object instances. So these instances are the ones with the actual text values, text color values, and text sizes. So what does one of these classes look like?
My God, that overwhelming knowledge.
We've created a simplified version of the TextView class, which would be saved in the textview.java file. We simplified it so it'd be easier for you to understand what a class would look like. First, it starts with an access modifier. It's marked as public so that other things, like an activity, can use this TextView class. Then we have the word class. This indicates to Java that this is a class definition. Then we have the name of the class. The name of a class in Java starts with a capital letter and it's in camel case, so there's no spaces and a capitalized subsequent words. There's some other text here, but we'll look into that later. The important thing is we have an opening brace, and then at the bottom of the definition we have a closing brace. Now inside this TextView class, we have a bunch of variables here. Each of these represents a field in the TextView. So we have a field for the text of the TextView and a field for the text color of the TextView. There are other fields as well, but remember this is the simplified version of the TextView class. We also have a variable to store a reference to the context of the application. You can read more about context in the instructor notes below, but it's basically a way to access information about the app. Like for example, you can access resources in the app using the context. And these are the methods of the TextView. The setText method takes as input a text string. Then it updates the global variable mText to use this new value. Similarly, the setTextColor takes as input a new color, and it updates the internal state to have this new color value. There's also methods like getText and getTextColor, which return the internal text string or the internal text color. One more thing, you may have noticed that these global variables here all start with the lowercase m. M stands for member variable, and these are all member variables of this TextView class. Member variable is just another way to say field or the state of the TextView class. Here's a simplified ImageView class. You would find it in the ImageView.java file. It starts with public class, and then ImageView is the name of the class, and then we have opening and closing braces. This makes up the state of the ImageView. Normally it would have more fields than this, but I just wanted to show you an example. This is an integer variable, and it's called mImageID, M for member variable. This stores the resource ID for the image that should be shown in this image view. Down here we have the constructor, which is used to construct a new image view object, and it takes as input a context, and then it initializes these variables. Then we have a method. It's called setImage, and it takes as input a resource ID for the new image that should be shown in this image view. Inside this method, we update the internal variable for image ID. Again, we created these simplified TextView and ImageView classes to help you understand the concept of classes. Now let's look at the real version of these classes inside the Android framework. To see the code for the Java classes in Android, you can install this Chrome extension. If you're not using the Chrome browser, you can see the instructor notes below for how to access these files. Okay. Once that Chrome extension is installed, then when I search for something like TextView Android and I go look at the reference documentation for this class, then there's going to be this extra link here that says View Source. This is really for advanced developers if you're curious about the code that is used to create this TextView. This is the TextView Java.
Fuck me, I'm gonna add. How do I do that? Chrome extension. I want the Chrome. What? Consumer and brand accounts. Backtop in Google Photos will not be deleted. Oh my god. Blah. It would be really helpful for me. But now
A file that was defined by someone on the Android team. As you can see, it's really long and complex, but it still has the main parts of a class. It starts with public, class, and then TextView, the name of the class, and then this is the opening brace, and the closing brace is all the way at the bottom here. At the top of the class, we see a bunch of fields here, and this makes up the state of the class. For example, we see that text color is a field. We also see that text is a field. And here's the constructor for TextView that takes as input a context. If I hit Command F or Control F if you're on Windows, then I can try to search for setText. And here's the setText method. This method is going to set the string value of the text view. And if I search for getText, then I also see this method returns the text that the text view is displaying. You get the idea, and you can browse through this on your own if you want. If I search for the ImageView documentation page, then I can click on View Source to view all the code for the ImageView class. The file says public class ImageView, and then these are the fields that make up the state of the ImageView, and then there's a bunch of methods at the bottom of the file. The code in this file is pretty complex as well, and it's also thousands of lines of code. The best part about object-oriented programming, though, is that you don't need to know about all these details. As a developer, you can use TextView and ImageView in your app without knowing about all the gory details of what's going on inside of it. In the last video, I briefly mentioned that a constructor is defined within the class, and it's used to actually create the object instances. So we call the TextView constructor to create this instance, and we call it again to create another instance, and so on. Let's look at the code for how to actually call a constructor. Do you remember how we created a new integer variable named quantity, and we set it to have an initial value of 2? Creating a new object and storing it inside a variable is going to follow a similar format. It'll look something like this. Instead of the int data type, though, we have an object data type. The object data type is whatever we call the class name. In this case, it's TextView. It can be anything as long as it follows the conventions for variable names. So we just call it price TextView. Then we set it equal to a new object, but we can break down this right-hand side further. The right-hand side follows the format of new, followed by the object data type, which is TextView in this case. This is calling the constructor defined in the TextView class. So we have parentheses with the input arguments to the constructor. So if the constructor requires a context object, then we need to pass a context here. Remember that the context object helps you access application resources and other things about the application environment. So altogether, this is creating a new TextView object by calling the constructor, and then it's storing this new object inside a variable called priceTextView. And this variable can only hold a single TextView object as defined by its data type. Here's another example of creating an ImageView object and storing it inside a variable. The data type is ImageView, the variable name is CoffeeImageView, and then we have the assignment operator followed by new ImageView. This is spelled the same exact way as the object data type here. Since we're calling the constructor and we have to pass in any inputs, we have parentheses and then we put the inputs in there. Here's a third example that creates a button object and stores it in this variable. The data type is button, the variable name is submit order button, and then we say new button to call the constructor. You can even define your own object data types. Say, for example, I created a class definition for cat view. Then I could use this line to create a new cat view. In this case, the constructor requires an input string for the name of the cat, so that's why I put tiger in parentheses and pass that into the cat view constructor. To determine what to pass as input to these constructors, you have to look at either the class javadoc file or the class source file. All these cases use the word new to create a new object. If we go back to the Java keyword list, then indeed we do find that the word new is in that list. Sometimes when you're looking at the documentation, it may advise you to use a factory method to create an object. That is, instead of a constructor. Here's an example. To create a new media player, the documentation advises you to use the method mediaplayer.create. And this returns a media player object that can be stored inside this variable. It follows the format of object data type, so media player with a capital M, dot, and then the factory method name, which is create in this case, and then you pass in the input arguments to initialize that media player. Here's another example of how to create a toast. A toast is a message that pops up temporarily in your app and then disappears. So the code starts with toast with a capital T, because this is the object data type, and then we have a dot, and then make text, which is the factory method name. And then we pass the input arguments to create this toast. To know what the factory method name is and what the input arguments are, you'd have to check the documentation for the toast class. In general, in order to know whether you should create an object using a constructor or with a factory method, you can just Google search for how to create that object. Using a constructor is the most common way to create a new object. It's less common that you would need to use a factory method, but to know for sure which one you should use, you can just Google search for how to create that object. Here's a chance to practice with creating objects.